Okay, so for today's lesson, I'm going to review a couple of problems, but to start the class out, I gave everyone poster board or poster paper to do a poster on. This poster is all about showing your polynomial division skills. So I've got a list of problems that I'm going to put out on Google Classroom tonight, and they're going to be numbered from 1 to 28. So whatever your desk number is in class, that's the problem number you're going to choose on the paper. So for example, if you're desk number 16, you're going to pick problem number 16, and that becomes your polynomial division problem that you're going to show. And I'll get those out there tonight sometime if you want to start now. If you don't want to start till the weekend, that's fine too, but don't wait till the last minute because we're at the end of the semester. There's no time for late. Okay, so let's look at what the requirements are. And I already have these on Google Classroom. So I said, can you let them in, please? Oh, all right. So in your Google Classroom, I'm first going to talk about your poster project. So you're going to show your polynomial division, long and synthetic. So you're going to create a poster. It's going to be divided down half, and on each side you're going to work the same problem. But on one side you're going to do it showing synthetic division, and on the other side you're going to show it doing the polynomial long division. Okay, so nice easy project. I think you will have for a poster. It should be pretty much fun. So here's the requirements, and this is a test grade, an assessment grade, so it falls in the 80% category, 80% of your grade, and it's going to be worth 60 points total. So don't skip it because it will drop your grade. If you're teetering on the edge of some grade, it could drop you below. With being at the end of the semester, no time to make it up, so don't skip it. So on the back, I want you to put your name and error on the back of the poster, not the front, because we're going to hang it in the hallways, and it'll be out there for quite a while next year. We don't want our names on the front. Okay, just make it the same for everyone. Put your name, first and last name. I'm going to have 100 of these things to grade, so both names and your hour. Now, each one of these have a scale, so it's going to slide. It's going to go between 0 and the max points for each thing that I'm asking you to do, depending on how well you perform that task. So 0 to 5 points for your title. The title must include your problem number that you're working on. So if you are seat 16, you get problem 16. You're going to put that in your title. And your title's up to you as long as it tells me what you're working on and has the problem. Let's see. For example, this is I put this together in like 2 minutes one day. So there it is, number 18, polynomial division, 4x cubed minus 3x squared plus 2x minus 3 by x minus 1. So there, I've got my problem, the number, and the title of actually what I'm showing here, polynomial division. Now if you want to do a full sentence, these are my examples, or however you want to write it, but it must include your problem number and the problem, and then your polynomial division. So you're going to divide it in half, and around all the edges I want a nice pretty border to make your poster stand out. So the border is worth 0 to 5 points. So if you don't put a border, you get 0 points for that. If you do a nice pretty border that took a little bit of time there, not just dots and dashes like what I did, you'll get all 5 points. I've seen some kids put a heart, like girls will put hearts and turn them all different ways or make them different colors and just do a little rim of hearts all around the edge. I've seen some people get like geometric shapes and put on there, like, let's see, did I leave it? Nope, I erased it. So like this, I've seen some kids do like a square in each corner, and then do something like get a yardstick and do nice pretty lines in between. That's a nice pretty border. That would get you all your points, but make it nice and neat. And I've seen some kids add a border of math problems like 2 plus 2 equal 4, and then they'll go another direction. 2 divided by 1 equal 2. Just simple little math problems written all over, 8 times 3 equal 24. Things like that. And then they go all the way, with them going all different little directions. I've seen them do that. Most of the times it's just like little geometric shapes or dots. I've seen girls do different colored polka dots, or like a dot and a dash, a dot and a box, something. You want to make some kind of border, or you might just get a big thick marker and just make like a bold line, then get the next different color and go inwards, and maybe do 2 or 3 layers of those colored lines. Anything like that would get you a nice border and all your points. Okay, so fill your poster, but use your white space appropriately. Make it hall-worthy. I always say hall-worthy posters, you want to draw people in to look at it. You want to be able to make it readable. So from a distance, you want to use your white space to make things stand out. So here's your heading. You're going to divide it in half, and you're going to have long on one side and synthetic on the other. But let's say if you just filled every single space and you did this and you wrote this and you got a big bunch of clutter, there's nothing to make anything stand out. What you want to do is use your white space to make things stand out. So make sure, you want to maybe do your problems here, and then maybe your steps over here, and same thing over here, but just make it nice and neat where it doesn't look cluttered. And it's okay to have space, but just not a huge block of it, like right there. Yeah. So if you have any questions about that, let me know. It's a good idea on your poster, work your problem out on paper first, make sure it's correct, double check it, and maybe plug it in a calculator and check it again, and then pencil everything in. Like you want to probably make your border first, and then I would take a pencil and just sort of lightly pencil in my lines, and then pencil in my steps, because you want all your steps shown, and then you want to explain each step, so leave space for that. So lay it all out very lightly in pencil, then go over it in your marker or your Sharpie. Black Sharpie does beautiful for your work. You don't want to use a yellow or an orange when you're doing your work here. You want to use yellow and orange maybe for some of your terms, or I've seen some kids write their explanations and they do the keywords in like a different color. I've seen so many different things. It's like, if you do what I'm asking you to do here, you'll get all your points. If you go above and beyond, I'll probably give you a few extra credit points. 0 to 5 points on each side. So when you divide it in half, you're going to get 5 points for showing along and 5 points for showing your synthetic. 0 to 5 points for each side for showing all your steps. Don't skip any steps. Show me from beginning to end how you did that division. Label the steps. 0 to 5 points on each side. So that means for each long and synthetic problem, when you label, you're going to get 0 to 5 points on the left and 0 to 5 points on the right for labeling your steps. And when I say label, I mean like find the difference. 2 or 3 words, and sometimes it takes a couple more, but you want to explain each step short and concise, and that should go beside your step. So beside each step, you should have a little description of what's happening. There's lots of examples in the book, and someone asked, can I use the same thing the book did? Sure, but with your problem. So make sure you get the right terminologies with yours when you choose them from the book. 0 to 10 points, overall effect. So I'm going to look at it and decide, is it very neat? Is it colorful? Is it easy to read from a distance? Just how much work? If you did a lot of work and you tried really hard, 10 points. If there's no effort put in there, let's say you give me half a poster of half a problem done in pencil, you're not going to get 10 points there. You're probably going to get 2. All right, so overall effect. how hard did you work on your poster? How good did it turn out? And then for every little error that you might make, hopefully there's 0, you'll get a -3. So let's say on the very first step you miss a negative sign and it causes every step thereafter to be wrong, you'll just get the -3 once. That even though that's where the error happened and it caused everything else to be wrong. All right. So any questions about that? Total of 60 points, and you've got the weekend. So have fun with it. And I like to do posters, but we've just, with Khan Academy and Nearpod, we're losing a lot of time. So this is a take-home project. Alright, so I'm going to pause this video for a second. I'm going to back up to 2 problems from yesterday, and I want to reiterate the word problem because when I just glanced at it, I did a 2-dimensional thing, and then I actually read through it this morning and realized, oh, this is cubic. There's 3 dimensions here. So I want to make sure I hit this with you, okay? It says this polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume. Volume is what? Length times width times height. It's cubic inches of the shadow box. So they give us the total volume here, and then they give us 1 dimension. All right, they tell us this is our width. So that means we have to find the length and the height. Okay, which one looks bigger? Which measurement? The length or the height? The length looks bigger. So after we finish all this, we know that the bigger number at the end is going to be the length and the smaller one will be the height. So let's see, how are we going to do this? Well, they gave us the width. So if we divide the width out of this polynomial, we're going to be left with the length times the height, right? And with everything we've been doing lately, can't we just hope that it turns out to be maybe a trinomial that we can factor into 2 binomials, and then we would have those 2 binomials, one being the length and one being the height. So that's where my mind's eye tells me this is probably going. So let's do this. We've got to divide the x plus 5 out of this polynomial. So let's start using our synthetic division. And so they start with, that's a plus 5, so what do? Flip the term, or flip the sign on the 5. We got a -5, put it in the box, and write every coefficient. Before we do this, you need to double check. Your first check should always be, is every power represented? If not, you need a placeholder. So we start with the cubic, so x to the 3rd power, 2nd power, that's x to the 1st, and the constant is just x to the 0. So every power is represented. So let's take all their coefficients. 1 plus 7 minus 38 minus 240. And that's what this is right here on the top line. Now, let me declutter this a little bit. All right. So now I'm just going to write over this. Remember, for synthetic division, you drop the first term, 1, and now multiply what's in the box against what you just dropped. So -5 times 1 is -5, and it goes in our next spot here, -5. Now add them. 7 minus 5 is 2. Now repeat the process. What's in the box? -5 times the number we just dropped. So -5 times 2 is -10. Pencil it in, add them. We've got a -48. Now, -48 times -5 is a positive 240. Now add them, and you get a 0. Your last term is always the remainder. Okay? Now, we know we had a cubic, and we divided it by a x term. So we know that our answer is going to start with x squared, 1 less, right? So this means it's going to be 1x squared plus 2x minus 48 with the remainder of 0. Okay, and here it is. Let me clean this up again. Here it is right there. Now, it is what I hoped for. It's a quadratic that I can factor. So, remember the back in the days of the magic x? What 2 factors of -48 add up to be 2? Oh, oh, negative 6 and positive 8. So there's your factor, x minus 6 and x plus 8. So one of those have to be the length and one of those have to be the height. And I said the bigger one's going to be the length. So what's bigger, x plus 8 or x minus 6? X plus 8. And if you don't see that or you're uncertain about what we're doing here, just write them, x plus 8 and x minus 6. Now let's just pick a random number for x and see which one's bigger. I'll just choose 0. 0 and 0. Now 0 plus 8 is 8, 0 minus 6 is negative 6. Oh, the x plus 8 is bigger. So that means it must be my length. X plus 8 is my length, and that means the other one, x minus 6, is my height. So the total dimensions here are x plus 5 for the width times x plus 8 for the length times x minus 6 for the height. And that's how you solve these. Are there any questions? All right, so I want to be sure and cover that one. Now let me do the last problem, the remainder theorem. It says if I divide a polynomial of a degree of n greater than or equal to 1, by x minus a, then the remainder is just p of a. It doesn't make much sense till we really look at it, right? It's just a quick way to find a remainder of a polynomial, and here's how we do it. And we know if we have a remainder of something, that means what we divided by is not a factor, right? Let's look at a plain number. Let's take this down to super simple terms. If I have a 3 and I want to find out, is this a factor of 21? That means I'm going to divide 21 by 3 and see if there's anything left over. If there's nothing left over, that means that 3 must be a factor. So 3 doesn't go into 2, but it does go into 21 7 times. So 7 times 3 is 21, and when we subtract these, I have a remainder of 0. Because I've got a remainder of 0, there was nothing left over. It means 3 goes into 21 perfectly. That means 3 is a factor of 21. Okay? Let's try it with a different number. Let's try 4 into 30. Okay, does 4 go into 3? Nope. Does 4 go into 30? Yes, it does. 7 times. 4 times 7 is 28. And when I subtract those, I get a 2. Does 4 go into 2? Nope. This is just a remainder. I've got 7 remainder of 2. Because I have some kind of remainder left over, it means 4 did not go into 30 evenly. It means that it's not a factor of 30. I can't find a whole number to multiply 4 by and get 30. You see that? So if we have a remainder of 0, what we're dividing by is a factor of that. If you have a remainder left over, then this is not a factor. And that's what we're going to use in larger scale for our polynomials. So it says to find out what is p of 3. Well, p of 3, we could do this the old school way and plug in a 3, and everywhere there's an x, we can put a 3 and see what it equals. But by golly, that's a big problem. Lots of powers to the 5th power, to the 3rd power. There's such an easier way to do this even without a calculator. Such an easier way. So the p of 3 by that theorem says, oh, well, they pulled this from x minus 3. Right? They're wanting to see, is this a factor of this polynomial? That's what the p of 3 means. And the sign is just reversed, right? So how do we find out if that x minus 3 is a factor? Do our synthetic division. So flip our sign to 3 and divide it. So there's what goes in the box, our positive 3. And now get all your coefficients. Let's see, we've got a 5. We're missing a 4 coefficient, so we need a 0, x to the 4th. We got a 5, 4, 3, 2, and we're missing our 1, just our plain x power. So it will go 1, 0, so 1, 0, there they are, -2, -1, 0, because we're missing that one, and then a 2. Everybody see that? And it might help you better to just write it out, x to the 5th plus 0x to the 4th plus -2x cubed plus, and so on and so forth. It might help you write it all out first, other than just wing it like we just did. Okay. So now that we have that, we're just going to do our synthetic division. And remember, you start off by dropping the 1, multiply by what's in the box, fill in the next spot, add, repeat the process. And you go down and you end up with all of these terms. This means that's the remainder. The last term is always the remainder. Was our remainder 0? No, it's 182. So that means that the x minus 3 is not a factor of that. But let's see, what are they asking us? What is p of 3? Okay, p of 3 is just 182. It's just the remainder. Okay? But in the next problem, we're going to prove, is that a factor or is it not? So, everybody see how to do that? Your answer is going to be the last calculation, 182. And your first problem set's going to be a lot like that, plus a little more. Okay? There'll be a problem just like this one on your test, though. Okay? Any questions about this? All right. Now let's move to our assignment today, and I'm just going to show you with the video. And we're moving on to 5.5, theorems about roots of polynomial equations. So if you will turn your attention to this video. And if we run up to the bell, your homework tonight is the evens on 5.5, just on the first side of the page. And after everybody leaves today, I'm going to work 2 or 3 of your problems from your assignment and put them out there online so you can model after, because this is really different from what we've been doing. So you'll have this video, and then I'll do one more video working out and giving you 2 or 3 of your actual assignment problems. Okay? So you'll have less work and you'll have something to model after. All right, here we go.
All the rational zeros of this function, 2x cubed plus x squared minus...
Hold on. I can't get it to go back. There we go.
Find all rational zeros of the function 2x cubed plus x squared minus 16x minus 15. If we want to find all the rational zeros of this function, we need to find all rational x values that will make this function equal to 0. Now we could go ahead and set this thing equal to 0 and try to solve for x. But that might be a little bit difficult because over here we have a polynomial of degree 3. So where else can we begin? Well, if we want to know all the possible rational zeros of this function, we can go ahead and we can use the rational zero theorem to help us know all the possible rational zeros of this function. In order to use the rational zero theorem, we first need to check that we have a polynomial with all integer coefficients. Well, 2, 1, -16, and -15 are all our coefficients. Those are all integers, so we can use the rational zero theorem. Now, in order to find all possible rational zeros, we need to know p over q. P would be all the factors of our constant term, and q would be all the factors of the coefficient of our leading term. So let's go ahead and write those down. Let's first find our values for p. We said before that our values for p are all the factors of our constant term. So all our factors of -15. Well, we could have plus or minus 1, plus or minus 3, plus or minus 5, or plus or minus 15. These are all the factors of negative 15. Now let's go ahead and find our values for q. We said before that our values for q are going to be the factors of the coefficient of our leading term. In other words, we need to find the factors of 2. Well, we could have plus or minus 1 or plus or minus 2. Now let's go ahead and find the values for p over q. And these values are going to be all the possible rational zeros of this function. Let's go ahead and take a look. We have plus or minus 1 over plus or minus 1. Now if we take about these plus or minus divided by a plus or minus, we're still going to get a plus or minus answer. So 1 divided by 1, we'll get plus or minus 1, plus or minus 3 over 1, so 3, plus or minus 5 over 1, so 5, and plus or minus 15 over 1, so 15. Now let's go ahead and look at dividing by 2. Again, our plus or minus is going to give a plus or minus answer. 1 over 2, we get 1 half. 3 over 2, we get 3 halves. 5 over 2, we get 5 halves. And 15 over 2, we get 15 over 2. Now we know all of our possible rational zeros. So some of these zeros could be our zeros, but we don't know which ones. These are just our possible rational zeros. Now, how do we know which ones are zeros of our function? We said before that if these are zeros of our function, if we plug them in for x, we should get a value of 0. Let's go ahead and try that. Let's go ahead and test some of these possible values in order to see if any of them are zeros. If we don't get any of these equal to 0 when we plug them in our function, that means that we don't have any rational zeros of this function. But we could have irrational zeros or complex numbers. So let's go ahead and try it. We said we need to plug in one of these values for x and see if we get 0. Let's start with positive 1. F of 1 would be 2 times 1 to the third plus 1 to the second minus 16 times 1 minus 15. Well, 1 cubed is 1. 1 times 2 is 2. So we get 2. 1 squared is 1. So we get plus 1. 16 times 1 is 16. So we get minus 16. And minus 15. 2 plus 1 is 3. Minus 16 is negative 13. Minus 15 is negative 28. This function value did not equal 0. That means that 1 is not one of our zeros. Let's go ahead now and try negative 1. Let's try f of negative 1. Well, that would be 2 times negative 1 to the third plus negative 1 squared minus 16 times negative 1 minus 15. Negative 1 cubed is negative 1 times 2 is negative 2 plus negative 1 squared, which is positive 1, so plus 1. 16 times negative 1 is negative 16 minus a negative 16 gives plus 16 minus 15. Negative 2 plus 1 is negative 1. Plus 16 is 15. Minus 15 is equal to 0. So that means that negative 1 is a 0 of our function. Now it may not come this easily. It may not be the second one you try. It may be the fourth one or the fifth one. And if you don't get any of these, that means that there are no rational zeros for your function. But it doesn't mean there are no zeros. We can have complex or irrational zeros. Now let's go ahead and take our 0 and see if we can use it. The factor theorem says that if negative 1 is the 0 of our function, then x plus 1 is a factor of our function. So let's go ahead and use the fact that x plus 1 is a factor to help us factor our function, f of x. If we want to factor f of x, we can take our function, 2x cubed plus x squared minus 16x minus 15, and if we divide it by one of its factors, x plus 1, we should get an answer with no remainder. Well, let's go ahead and see what we get when we divide by x plus 1. Here we can use synthetic division to perform this division. We need to look right here at this number, positive 1, and we need to take the number with the opposite sign, negative 1, and we write it in a box. Next we look at our coefficients, and we write them up here. So we get 2, 1, negative 16, and negative 15. We draw a line, and we bring our first number down first, 2. We take our number 2 and we multiply by the number in the box, negative 1. 2 times negative 1 is negative 2. We write it right here. We add these two together now. 1 plus negative 2 is negative 1, and we write it right here. Negative 1 times the number in the box is negative 1 times negative 1, or positive 1. We write it right here. We add these two together, so negative 16 plus 1, and we write that right here, negative 15. We take negative 15 and we multiply it by the number in the box. So we get negative 15 times negative 1. That's positive 15. We write it right here. We add these two together. Negative 15 plus 15 is 0, and we write it right here. That's our remainder. We expected a remainder of 0 since we know that x plus 1 is a factor of our function. Now these are our coefficients of our polynomial. Since we had a third-degree polynomial divided by a first-degree polynomial, this will be a second-degree polynomial. So this is our coefficient for the x squared term, this is our coefficient for the x term, and this is our constant term. So let's go ahead and write it. That means f of x factors to x plus 1 times 2x squared minus 1x minus 15. Now if we're trying to find zeros of this function, either x plus 1 has to be equal to 0, or 2x squared minus 1x minus 15 equals 0. We already know that when x plus 1 equals 0, we get the 0, negative 1. So now let's go ahead and find out when 2x squared minus 1x minus 15 equals 0. So we need to find the x values that make 2x squared minus 1x minus 15 equal to 0. So we take 2x squared minus 1x minus 15, and we set it equal to 0. We just have a quadratic equation. We can either factor or use the quadratic formula to solve. Well, if we factor, we set our two parentheses up, and we need to multiply two things together that equal 2x squared. We could write 2x and x. Next, we need to multiply together two things that would equal negative 15. So one's going to be positive, one's going to be negative. Well, we could pick 5 and 3, and we'll put the negative on the 3, the positive on the 5, because that would give positive 5x, negative 6x, which gives a negative 1x. And this has to be equal to 0. So, either 2x plus 5 equals 0, or x minus 3 equals 0. Now let's solve for x. We subtract 5 and we get that 2x equals negative 5, or x equals negative 5 halves. So x equals negative 5 halves. That means that negative 5 halves is a 0 of our function. Now let's go ahead and solve the other one. We add 3 to both sides and we get that x is equal to 3. That means that 3 is another 0 of our function. So let's go ahead and list all the zeros of our function. We found originally that our first 0 was negative 1. Then we found our 0 was negative 5 halves, another 0. And lastly, another 0 was 3. So we found that this function, a polynomial with degree 3, had 3 zeros, negative 1, negative 5 halves, and 3. And more specifically, it had 3 rational zeros. And if we look back at our list of all the possible rational zeros, we see that negative 5 halves, our actual rational zero, was on this list, right here. And our other 0, 3, was on the list right here. So now we know how to find the rational zeros of a function.
Okay. So we finished with a lot more time than the other classes. So your assignment is actually going to be 2, 4, 6, 8, 10, 12, 14, 16. And I'm going to work a few out of those and put them online tonight. So I would like for you to, I'll put this back on the board and freeze it, for you to start working these.
Find all rational zeros.
Let's do this. I'm trying to find a good spot where. Pause there. So use this as a guide to solve your problems and start working on your homework, and you've got several minutes, okay? So that's everything for the first half, and then tomorrow we'll finish this. Oh, also pass forward your 5-4, and that concludes our lesson. Thank you.